All right, everybody. Welcome to Chapter 16, MechFest. MechFest. All mechanisms all day. We're going to learn how to make a hydrate from an, well, in this case, a ketone. But could be an aldehyde, just isn't in this case. From now on, this chapter, when I want to say it could be an aldehyde or ketone, I'm just going to write this. Watch. Ald/ket. Okay? Same chemistry exactly. And this would be water if this R group was a hydrogen, and this would be an alcohol if the R group is carbon. Same mechanism, but we do two different things. If you're using water, you're going to get what's called a hydrate. That should be no surprise, because the extra is water. HO here and H there. That's extra. That wasn't there before. Not surprisingly, it's called hydration, adding water. It's not the first time we did a hydration, is it? No. In fact, we've done this very hydration. Yes. Chapter 10. When we had to oxidize an aldehyde in chapter 10, we first made it into a hydrate so that we could make an ester from this with chromic acid. Vaguely remember that, maybe. Review that. It's chapter 10. You know it's important. Okay? We're getting started here. Acid catalyst, sulfuric acid, or hot. Anytime we use sulfuric acid, you can use hot as an alternative. One of the main themes in this whole chapter is carbonyls like to be attacked, but only if the nucleophile is a moderate or a strong nucleophile. If you have a poor nucleophile, which we do, you are going to need a catalyst to activate the carbonyl. If you can just keep saying that to yourself, activate the carbonyl, that tells you how to start. You need to put a proton on the carbonyl oxygen. Okay? So if you see an acid, like sulfuric acid or hot, and an aldehyde or a ketone, you're probably going to protonate the carbonyl first. And it works in these two mechanisms, and it works in other mechanisms later. So we are picking up a proton from our strong acid. Equilibrium. Every step is governed by the equilibrium in this process. Now we have what's called an activated carbonyl. It'll be attacked by any nucleophile, even a poor nucleophile, which is the next step. Poor nucleophile attacks the activated carbonyl. Wouldn't do it otherwise unless it was activated. No activation, no reaction. So please acknowledge you know that by protonating the carbonyl first. And you've got your new stuff here. Sorry about that straight line. Let's get rid of it. O bonded to H bonded to, in this case, R. Remember, R's is H or carbon. And we also made in step 1 HO3SO minus, and I believe the mechanism is almost done. Don't you agree? What's the only step that remains? Use the sulfate to take the proton from the oxonium. I paraphrased for you. She was saying that. And that's it. It's not a bad mechanism, is it? We like it because we know it's good for hydration to make a hydrate, where this would be an H, and it's good for hemiacetal formation. We'll talk more about hemiacetals in the next video, because first 3 videos all involve hemiacetal and acetal to some extent. No acetal here. And we will leave it at that. And we'll come back with our next one.